All right, let's get this going. Okay. Mic is on. Good. All right. I am still working on my Ultimate-Tic-Tac-Toe bot. Yep. And reworking it, actually. Using a lot of bitwise operations, and bit masks, and bit boards, and lots of bits. Bits. And it is confusing. I'm going to have to be really careful because as this is growing, it's getting kind of confusing, and if I want to change things, like I really need to probably encapsulate some of these, or hide away anyways, some of these bit manipulations. But I'm also trying to optimize for speed, so I'm wondering like what would be the impact of instead of just straight setting bits like this, or testing if a bit is on or not, and things like that, straight like hard coded in my logic. If I try to make little functions for, like, flip bit, and then or I don't know, set bit or clear bit, or I don't know how much of a hit it would have on performance. Kind of. So right now I've just been like putting comments. This is not maintainable code by any stretch of the imagination. So I really don't know, because I'm really trying to squeeze in as much performance, or squeeze out, should I say, as much performance as I can. So that often goes at the expense of readability. Anyways, we'll see. As this thing grows, if it really becomes like really hard to understand what's going on, I might make some changes. All right. So the thing what was I doing now? Oh yeah, I had finished apply actions. No, get possible actions, right? Where I need this function to take in a state, and I need it to spew out all possible actions given that state. Cool. So all that okay, yeah, I gotta test it to make sure it works properly. I'm done implementing it, but just wanted to make sure everything worked properly. So I have a board here. Let's just make it completely empty. That'll be our first test. So as we're beginning the game, we're going to be setting it that way probably, and let's say player X is the first one to go, and the entire board is empty. So technically possible actions should be like everything, and I'm getting nothing, so we have a problem. What if I just tried no difference. Okay. Alright, let's figure this out. Alright, if it's the game's first move, or the small board is closed, all boards are open to play. So the board index we're getting should be 0. No, hold on. 15. Oh, yeah. Yeah. Right, we did set that to, yes. So see, that's the binary value of 15, so that's fine. So that's good. Now what we're saying is if board index is bigger than 8, which it is, or we don't care about that. So what are we supposed to do? We're supposed to check this iterates through each board, right? So iterate iterate through each small board. That's what we're doing here. All right, and now as we're doing that, state I is starting at 0. So we're starting with board 0 now. Check if board is not closed. And it's not closed because we're going here, that's fine. Actions.concat get small board actions. What do we have here? So it is getting the actions properly. Oh. Oh yeah. That is a problem. Gonna need to fix that. But first, why isn't it oh, can you not concat to an empty array? Is that what's going on? No, that shouldn't be the problem. So we are getting, what are we doing here? We're there, yeah, okay. I don't often use concat for some reason, but let's see, const r equals an empty array. Now let's say we've got another array here. Let's just call it array 2, which does have things in it, 1, 2, 3, and then we go r.concat, then array 2. Variable r implicitly is an any type. Yeah. Whatever, dude. Not what we're testing here. So this, okay. Combines two or more arrays. Yes. And now, what do we've got here? It's still empty. Oh, unless, wait, 2 concat r, would that be, no. So it looks like if the array is empty, let's say I was going to do 4. Oh yeah. The heck. How does this thing work? It's not very helpful. Additional items to add to the end of array 1. Yes. Precisely. So why aren't you doing it? Alright. To look at the documentation. two arrays. Array1 dot concat array2. Oh, does it? It probably doesn't mutate. It returns a new array. Returns a new array. Yeah, that would have been helpful in the IDE, dude. You know, like. Okay. So there's our explanation. That takes care of that. Now let's fix that. What are we doing here? We are so I guess we need to. Oh, that's annoying. I don't want to do it that way. All right, then let's not use concat. Let's just go ahead and do actions. I could just use the spread operator. I don't know if it's faster or not, but if we do actions equal, since we have to create a new array anyways, well, I could always push it. Nah, we're creating a new one anyways if we use concat. So if I do it like this, actions, boom, boom, boom. Wait. Right, I need to do this as well, right? So that's one way to do it. I don't know though which one is more efficient. Because another thing I could do is I could leave this as const. I could do let's see. I could also do actions dot push like that. Yeah. What are we outputting here? We are outputting our actions. Good, 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 good. If I look here, yeah. Now the problem is, the problem is that we're not getting, see how we're getting 15 here for index 0. Index 0 in this 8-int array is supposed to be the index of the small board to play in. Now 15 is not a board. We've got board 0 to 8. Now the problem is that I'm setting at the very beginning of the game right here just to let my algorithm know that we're beginning the game and you're free to use any board you want. I'm setting it to 15, and right here I am detecting if it's bigger than 8, right? So if it's bigger than 8, and 15 is, then you know that you're allowed to play on any board. The problem is that in this function here I am kind of extracting these bits here to make my my array here and tell and say which board I'm playing in. And normally this would work fine, except for the very first turn where I'm setting it to 15. So let's think about how we can fix that. This is it here. See, there's a culprit. I am board index. I'm passing in the board index. The board index here is 15. So how am I going to do this? I could, let's see. That was a nice, easy way to do it. How else would I know where I'm playing? Well, we could pass in. We could pass in this here instead of the board index. It comes down to the same thing, really. Yup. So let's pass in I. This is fine though. But for the loop, we're going to pass in I. And this should work. As you can see. Now what we should be seeing, since I'm testing, the configuration I'm testing right here is the very beginning of the game. Player X is to play. That's this bit here. 1 is player X, 0 is player O. This is the flag that tells us, say, this is the very beginning of the game, basically. And as you can see, everything's empty. We don't have any X's, we don't have any O's, or X's and O's. Here too. So technically, my get, what did I call this function? Get possible actions should return every single spot on the board. And let's see. So we should have index 0 to index 8. We do, right? Meaning every single small board in the game. And we should have here as well index 0 to 8 for every single board, meaning every spot, spot I guess you call it, is also open to play. So 0, 1, 2, 8, 0, 1, 2, 8, 0, 1, 2, 8, there we go. Okay, so this works. Yay. Now let's try another configuration. Let's see, let's pretend that we now have to play in board index 8. So that would be 1, 0, 0, 0. And that, let's see, so this is the one here. And we are, okay, let's say there's only one spot open. And this would be, doesn't make any sense. This is not a valid, oh no, it could be, it's true. It could be that way. But anyways, so basically, we've got X's everywhere. No, it wouldn't be because you would have won. But anyways, we've got X's everywhere except for index 7. So that should be the only action it returns. And let's see. And it doesn't. It returns actions for every single board except for board 8. Haha, that's interesting, when it should be the opposite. So what's happening here? We are, okay, so this is a problem right here. It should be skipping this. Board index is bigger than 8. It's not. It is precisely 8. So this must be the condition that's being triggered. which is meant to check if the board is open or closed. And right now, the way I've got it set up, board open or one would be board closed, and we're set to 0. So let me just see to make sure my board representation is fine. Yeah, so this would be the bit here. This bit here on every small board is meant to be a quick way to check if this board is done, if someone has won or if it's a draw. And that's what I'm supposed to be checking here. How the heck am I doing that though? Alright, so I'm getting the board index, fine. And then I'm doing an end. I'm doing an end. 1. So I'm checking bits 18, right? I'm checking bit 18. No, I'm checking bit position 17. Is that the right one to check? It's not. It's bit 18 that I need to be checking. And that's why my problem, that's why I'm having a problem here. This 0 index crap is... Alright, well, let's see. Yeah, there we go. Business we are. Okay, we're getting 8 and position 7. Board 8, position 7. So there was just a off by 1 error. I have a feeling there's going to be a lot more of these. All these magic numbers everywhere. All in the name of optimization. And I don't even know if it really makes a difference. That's the funny thing. Talk about premature optimization. Okay, so that's okay. It works in this scenario. Now let's pretend that this board is full and it's now closed. In this situation, our algorithm should return. It first looks into it and says, "Oh, look at that! I'm supposed to play here, but this board is closed." So then, cool, I get to play wherever I want. And let's see, what are we returning here? We are returning every single other board except board 8. Exactly. Now let's also pretend that board index 2 was closed. It should be skipping that one. So we've got index 0, we've got index 1. What? We've got index 2. No. 4, 5, 6, 7, 8. Okay, so why? Let's see what's going on here. Oops. So we're looking, we're saying, oh, board 8, cool. Now we'll check this here. Oh, that's because I've got the same check, but I did the same error right here. So this should now, see, that's why duplication is bad. It should now skip index 2, and it did. Good. Good, 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 good. Okay. Now, let's check to see what happens when we're straight up. Okay, we're telling it here to look at a board that is closed. That's cool. Is there a situation that we haven't tested here in our function? This tests everything here. Oh yeah, a simple situation where the board is open. Oh no, I think I tested that first. Well, let's do it again just to be sure. So let's say I'm saying board index 4. Board index 4 is here 1, 2, 3, 4. And let's say got this one here, and this one there, and this one here, and this one there. So what do we get? Board 4, good. 1, index 1, that's right, index 1 is not taken. Index 3, so 2, 3, index 3 is not taken. Index 4 isn't taken either. Neither is x5, no 6 is, 7 is free, and 8 is taken. Good. So alright, I think we're in business. I am satisfied with this. So, of course I'll have some automated tests, I guess, once the whole algorithm becomes more clear and cemented, because this might all change, and I don't want to waste a bunch of time writing tests for this if it's gonna be changing every 5 seconds, which it has been so far. Like, I'm not even clear on my model here for representing the game and actions and all that. So alright. So we're done with get possible actions. We're done with apply action, which we were implementing because we need to, yeah, I think this is where we were in the overall algorithm for this AI. So let's just stop Quokka here. Bring our research paper here for expand. Let's see. We were right. So I've got tree policy implemented. Kind of, right? Let's see here. Tree policy, yeah. Although it's calling stuff that hasn't been implemented yet. So I'm wondering if I should work on that first, or while node is terminal. It's not terminal. So I've got my node class here. I haven't implemented this yet. Possible actions left to expand. This should be an array of action, just to make sure we're doing this. So, okay. Cool. Yeah, this is kind of important. Maybe I should look into it. Node is not terminal, so I need this to return a boolean if the game is over. How do I determine if the game is over? Right now, if I look at my model, I have set aside a bit 23, to determine if the game is over or not over. So it would be a simple matter of checking that bit in this, but I do need to make sure that that bit is being set properly somewhere whenever the game becomes over, and that would be in the apply action. Right? If I apply an action that causes the state to now be game over, I need to set that. So I need to make an actual check here of all the boards to see if we're winning. If there's a win, or if there's a draw, or yeah. Yes. Now how do I do that? So this would be something that I need to do right here. So check if metagame is over and set appropriate bit. Well, actually, yeah, we'll just say that, but appropriate bit, which should be bit 23. Right now, that's what it is anyways. And there's a danger too with code comments, right? Because now if I change this, my model here, and I forget about that, then I'll have a comment that says, oh, we're flipping bit 23 here, but when really we shouldn't be. And anyways, I can't imagine how people used to code in just straight binary and even assembly. That must be crazy. I don't know. All right. So let's think. Let's take a look at this here. That's a good example. So this is the bit 23 here that we would need to flip, or set, should I say, if ever the game becomes over. Now, how do we determine if the game becomes over? I already have a mechanism to set. Let's see. Let's just return that to 0 everywhere. These here are a representation of the overall game. So these are all the small individual tic-tac-toe boards. This is the meta board. X's, O's. So if ever, for instance, this board here, X wins this board, I would now set the field for, this would be index 0, so index 0 for X. This would now become 1. Boom. Okay, so checking if X is winning the entire game is a relatively easy thing to do. It's actually the same algorithm I'm using to check if a small board is being won, and that was the idea. I made it that way purposefully. Now the problem I'm seeing is, how do I detect a draw? How do I detect a draw? That's the problem. Well, let's see. How do I detect a draw right now? I'm simply checking that is okay. For small boards, anyways. I'm simply checking that every single position has been taken. Now, here's the problem and why I can't use that on the meta board. Because it is possible to have a draw on a small board. It means it's neither a win nor a loss for any of the players. So if we have a draw on small board index 0, I'm not going to be putting a win for X or a win for O. It's a draw. But how do I represent that in the meta board? Right now, I'm not. So maybe I should be. And I was at some point, then I thought it was too complicated, or it was superfluous. I didn't need it. And I think the idea was I switched, because I was using that to see if the board was closed, and I simply switched to having this one bit here. Oh, so that's one way that we could do, but then that requires us iterating through the entire thing. If I can avoid that, that would be great. So maybe I should go back to having also an 8 or 9 bit space for representing drawn boards. Now the other problem that causes is that I'm now over my 32-bit limit, which means I need to I've been moving this around so much. This part here, these bits that represent whose player's turn it is. Whoops. If the game is over and what board we're supposed to be playing. And I've been moving these between index 0 and what a pain. It would make it so much easier. Like, okay, let's see. 4, 5, 6, 7, 8, 9. Now, all I would need to do to check if the game is over is shift the bits, and do an AND, right? So shift the bits here, boop, do an AND, and shift all of that there, do an AND, boom, and I'd end up with a 9-bit number where you know, every one or drawn board would be indicated by a 1. So I would simply need to check if this was all ones to know whether the game was over or not. Or, well, anyways, if the game was a draw. The overall game was a draw, because there's no more, you know, it's not possible to play anywhere. And I already have something easy that I'm using to check if it's a win. Really see, okay, what's the alternative to doing that? The alternative to doing that is it's checking, it's iterating through each of these to see if this bit is checked, is set, which I would think is yeah, that's not going to be as performant, right, as doing this here. Definitely not. Damn. Okay. So now if I do that, how many bits do I have? I'm pretty sure I need to move these. I've got 23 bits. If I had 9, yeah. Actually, I don't have 23 bits. I've got 24 bits. This is 0 indexed. Crap. So I would need to move, well, at least 1 bit to board 0, for instance. Well, and if I'm going to move just 1 bit, see, this sucks. This sucks because this was all neat, right? I had all my metaboard information right here. And this was all small board information. It's not gonna screw anything up if I move it around. It's not, because I'm 0 indexing this from the right, so it's not a problem. It doesn't mess with the algorithms I'm using for these. It's just conceptually, you know, it was kind of cool to have everything related to small boards in their own bit word, or whatever you want to call that. There really is no way to get around it, unfortunately, that I can think of. So just to save some trouble, though, I could, actually would be less trouble to move all of this, because then the spacing remains the same. Oh, but I really don't want to. It means I need to go and retest everything, and yikes. See, that's why I don't write the tests yet. Is there another way to do this? Like, if I really don't care about performance, I would do it the other way, but I kind of do. That's the whole purpose. So, grrr, let's do it. Let's bite the bullet and do it. Alright, so this now is going to be here. So I need to change this here. X is going to be here. Now I've got an additional one of these. Alright, so now that means that bit 23, game is over, game is not over, is only for index 0, not index 9. Bit 22, player X to play, that's also going to be for index 0 now, not index 9. Bits 21 to 18, index of valid board for, that's also now on index 0. Okay, now I need to add, no, that's actually not right. That's actually not right. This is now bit 24 and bit 23 and bit 22 to 19 because bit 18, yeah, okay. So then let's make this here, actually, yep, bit 18 through 27, if I'm not mistaken, no, through 26, so 26 through 18 are going to be position, no, actually, small, drawn small boards, and that is only for index 9. Right. Now I need to change all my algorithms. So whereas I was checking for the board index here, I now have to check it in here. And it's no longer shifting by 18 bits. I gotta shift by board index by 19 bits. Okay, now here, same thing, 19 bits. Nope. That's not right. Wait, what are we doing? All boards are open to play. No, this is still 18, okay. But this is 19 now. Yeah. Okay, now state board index by 9. Get small board actions. Getting the board, that's fine. This is fine here. But this here, flipping the player flag, now happens on 0, and it's actually now bit 23. So crap, I need to change this. Ugh. Right, am I mistaken? No, it is bit 23. Bit 23. So what is, alright, let's do that. So if I do B 1 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. All right. So that is what we get in numbers 4194304. And if I was to show me what it is in base 16, 400,000, and what did I have here? 40,000. So is it as simple as that? I didn't really think about the math, but where was I? Where is it? Oh, there it is. No, that's already what I have, 400,000. So, something wrong. Oh yeah, that's because it's 0 indexed. Forgot that one. There you go. 800,000. Which makes a bit more sense. 8608. And base 16 would be 800,000, so I could represent it like this. 800,000. Let's do it that way, I guess. Bit 23. Bit 23. This is horrible. Okay. What now? Reset next board bits. Not that also changed, didn't it? Next board bits are now 19. Yeah. So this would be 19. Nope, that's not the one. This is the one. Reset next board bits 19. 19. Set closed flag on small board. That's fine. That didn't change. Set appropriate one flag on meta board. Okay. That also doesn't change. But if we're drawn, now we need to change that. We also need to set closed flag on small board and set appropriate drawn flag on meta board, which will be, we don't care about the player, we just care about, so let's see, new state. We're going to be taking in, okay, so that's index 9. We're setting that to basically action 0, except I first need to move this by, well, by 18, right? Yep. Alright, now I gotta test all this stuff again. so let's make sure that oh, I thought I had an apply action here. Apply action takes in the state and an action. Cool. So let's start by testing that. Make sure we didn't screw that up. So let's say it is player X's turn, and we are applying to board index 1 and position index 2. We are getting our state back. Let's forget about this for now. And let's see what this looks like in actual binary. Oh no, that is the opposite of what I wanted to do. I wanted to check this out, yes. So just looking at this, our initial state, our index 0 is changing, and that's quite normal because we should be flipping the player to 0 here and setting this. Here, let's set this to 0 for now. Sorry. And we are setting a bit on index 1, and that's what we're supposed to do. We're supposed to be setting bit 2, and setting bit 2 would give us the number 4. Would it not? Yes, it would. 1, this is 2, and this is 4. Yeah. So that works. Now, and we're about to find out if this also works. We're now where we had a whatever, so we had this here set to 1. Now we obviously flip it to 0 because we now have 0 for index, so that's good. Now I'm interested to see what we're doing with 9. 9! Let's switch that to binary representation. Okay. So we set 1 bit here, and it should be technically, what should it be? Why would we flip a bit on 9 right now? There is no reason to do that. Why would we set a bit? We're not drawing, we're not doing anything. What bit are we setting? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We're setting bit 20. Oh, I know what's going on. Yeah, because this shouldn't be 0. We should be flipping, yeah, this is what's happening. Okay, so just one thing that we forgot. So set next board bit, yeah, this needs to be 0. There we go. Cool, so this remains 0. That's what we want it to be, because there's no wins, there's no draws. And this now becomes, and we're setting bit, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We're setting bit 20. Bit 20 is the equivalent of 2 in binary for this range. 0, 1, right? So it's the equivalent of 2 And that would be correct, because we have just played, was our action. We have just played in position index 2. So the next board, the next board to be played in is going to be index 2. Good. So I think we've got that in terms of applying action. Let's just change that to 0 to see what happens. Now technically the player playing it should be 0. Oh wait, that's wrong. Is that the player playing, or is that the game flag? What is it? 23. Player. Oh yeah, that's the player. Okay. So if player X is playing, we're playing in board 1, position 2. We've got 0 here now. It's no good. I thought it was working before I changed. Wait a minute. No, it wasn't. Why did I think it was? That's weird. So if we're looking at index 1, oh right, it is working. It's because this is the state before we apply the actions. That is why. So if I look at this here, this tells me what's going on. Okay. So we're set. So that's wrong. That is wrong because X is playing and we're setting O's bits. What if I put it to 0? Then nothing happens. Yeah. Okay. So we've got a problem with our, let's see, apply action. Player is X, new state, so who's the player here? Oh, I can't check that. Can't check it here. Let's try it here. Is that gonna work? No. Should work here. There we go. So it's saying that player is 0. Obviously it's not. And that's because it's checking on index. This is 9, it should be 0. There we go. And we have fixed it. We have fixed it. Man. Yep. There we go, 2048. 2048, which would be next one, 2 string, binary. All right. 1, 2, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 2. Perfect. 2. That's what we wanted. And we're flipping the bits properly now. No, we were already, so that's the problem. Right. 0 index here should be, actually, oh yeah, because we're setting the next board, so that's fine. That worked. Okay, so now we're done with our apply action, I believe. Believe that we are. Could always make another test. Let's say board 8. Boom. Board 3. Boom. Position 1. That's right. If I flip this to the other player, boom. Yep. Okay. Satisfied with this. Although, let me just check apply action here. If it's drawn, if it's on, okay. We'll get back to these later. This is all I'm doing right now is so that I can get to this. Okay, so now I'm checking get possible actions. Get possible actions, Q. So let's say we are player X is to play. The game's going on. We're asking to look at board 1 and board 1 is empty right now, so we should technically get all possible board 1s. Yes. Board 1s, 0 to 8. Cool. Now let's say this is the beginning of the game. Boom. I should get every single board, every single position. 1, 2, 3, 4, 5, 6, 7, 8. Good. If let's say I'm saying you should be playing in board 8, but unfortunately board 8 is full. 1, 2, 3, 4, 5, 6, 7, 8. Will it still allow me to do that? It won't. But, okay, that's true. This would never happen like that. I would have the set flag, and that's what I'm checking. Yes. So now it's giving me everything but board 8. Good, good, good. You know, I am indeed setting that flag, am I not? Let's test that. So let's say, all right. Let's pretend, boom, boom, and we are saying play board 8, position 8, and your player X, good. So if I do that, I end up with this state here. So board 8 should now have its bit set. It's that's bit 0 to 8. That's 9 through 16. Bit 17 should now be set. One, 2, 3, 4, 5, 6, 7, 8, 9. Boom. Okay. So that works fine. Now what if, let's see, what if we're winning? It's not a draw, but it's a win. Oh, that's interesting. What's going on here? We're setting, oh, right. Silly moi. let's do it the other way again. It's like, what's going on here? There we go. Yep. Okay. It detects that it's a win, and it sets the board closed bit properly. So that's good. Let's just make sure it does the same thing with player O. But I don't see why it would be a problem. So if we're doing this, boop, boop. Yep, we're getting our win flag, our board close flag. And what if we're going to get a draw? Yep, we're also cool. Let's just bring that all back to zeros. So that's good. Okay. So back to getting our actions. We want to check. Okay, so player 0's to play. It's being asked to play in board 8. Board 8 is closed. It's going to give me everything else. Right? Yes. 0, 1, 2, 3, 4, 5, 6, 7. Now let's say that board index 2 was also closed. 0, 1, skips to 2, 3, 4, 5, 6, 7. Good, 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 good. Okay, so that's good. Now, if... Oh, really, that's pretty much the only thing Well, let's just make sure. Okay, let's just make sure that it deals with this properly. So now it should give me all but index 1 and index 5. Yep, okay. We're good. We're good. Didn't break anything. Well, we did, but we fixed that. Now we get to implement this. Check if metagame is over and set appropriate bit. Okay. I need to check two things. If it's drawn first. And that's a pretty easy one because I have a drawn board representation. So what I need to do is if is draw. Actually, no, that won't work because it's actually simpler than that. All we really need to do is check let's see, new state 9 and I need to move that. Yes, I need to move that by 18. And then I can check. I can do end 511, which is 9 bits set to 1, I believe. Right. And if would that be the only way though? No, that's not the right way to do it. This just checks if all small boards are drawn. That's not the right way to do it. What I really need to do is exactly what I'm doing here, except that I need to add one layer to it. So this is what I need to do. New state 9 or so I bring that over to this one here. And then one more, all of this. So all of this gets a new state. Ay, ay, ay. Okay, this will be 18. And then all of that is checked against these. Yes, okay. I think that's right. And now what happens if we do detect that we have a draw, then we need to set the bit which bit are we setting? We're setting a bit 24. 24. Yes. All right, let's test that right away because I am not all that confident in what I just did. So we're starting off, well, we don't care. We just want to, let's see. Apply an action that would cause us to have a draw, basically. We don't really care about the inner workings yet. Let's see, how are we gonna, okay, well, one easy way to test, obviously, is if all of these, how many do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. It's if I am being asked to play in board 0. Position 8, sure, why not? And let's pretend that board 0's got, let's just use the other one, it'll be easier. Board 1, there we go. And we're player 1, player X wants to play. And we already have, let's pretend that all of these are already taken. So by doing that, we should now have a drawn board. And this becomes a drawn board here. And this, if it's all drawn, then obviously the game is over. And we should flip this bit here, bit number 24. Bit number 23, I mean. Nope, it should be 24. See? Bit 24. Alright, so, okay. Let's check. What do we get here? Let's look at the overall state first. Okay. So we do see that it's changed the state in 9. So let's take a look at that. Correct. Now we have the entire drawn boards taken. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Now the question is, did it flip the bit 24 in index 0? It did. It did. Oh, that's interesting. Hold on. 1, 0, 1. It should have flipped the player to 0. So if this the player, this should be 0, then it's to 1, but then what is that? Oh, it's 8 for the if we were to keep playing, yeah. So that works. Well, would you look at that? Okay, let's do another scenario where 1, 2, 3, 4, 5, 6, 7, 8, where we're getting a draw, but we're getting a draw through a mix of drawn boards and X and O's ones. So let's say this one is a draw. This one is an X1. This one's an O win. And so we're at index. Start from here. No, let's keep going. 0, 1, 2, 3. So this one's a draw. And then 1, 2, 3, 4. So 1, 2, 3, 4, 5. Win. Then 1, 2, 3, 4. Win. And then crap. Let's do it that way. 1, 2, 3. 1, 2, 3. 1, 1, 2, 3. 2. And then 3. Then nope. What? Am I retarded or something? This one should be okay. Something doesn't work. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we're missing one. That would explain. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this should work. 1, 0, 0, and this should be 1, 0, then 1, 0, 0, 1, 1, 0, 0, 1. Good, good, good. Okay. And well, then we don't really care where we're being asked to play, right? We're never going to get oh yeah, so I shouldn't. Okay, let's not set this one here. Actually, let's not set this one here and make this an X win. So we're going to be playing, there you go, 1, 8. So this would be flipping this, making this a win. The win is going to be registered here, boom, making the entire game a draw. Unless somebody's winning in my... I don't think so. 7 is the middle, yeah. So that's correct. It does detect it as a game over situation. Well, what if this wasn't? Still detects it as a game over because there's probably some kind of winning condition in here and I didn't think about. Maybe diagonal or something. Okay. Yeah, this would be hard to get an actual drawn game, I think. Oh, maybe not. All right, let's think about this. I want to fill up the board without anyone winning. So this is corner here, so 1, 1. Well, actually, okay, let's make this real simple. You've got this one, you've got this one, the other ones are all drawn. 1, 2, 3, 4, 5, 6, 7. It does detect that the game is over. Cool. Hmm. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now it's always setting the game as over, no matter what. Oh. Okay, I've got this all wrong apparently. We got the 1 bit here set. Now if I am to play here, yeah. Nope, that's wrong. Oh, crap. Oh. Wait a second. No. So what bit is that? Zero. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So bit 17. Yes, that's correct. And then 18. And then, okay, that's correct. I see what's going on. So let's say if I was to do 0 instead. Yeah, and it sets player 1. Cool. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, so that doesn't work. Yeah. Doesn't work at all from what I can see. So we correctly indicate that the next player is 11, is X. We correctly indicate that the next board we're going to be playing is 8. Oh yeah, and we correctly indicate that the game is over. If I was to do this, doesn't change anything. Oh, that's interesting. Okay, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, okay. So now it's not saying the game is over, which is correct. But if I was to start doing this, boom, right away it says the game is over. 2, 3, 4, 5, 6, 7, 8, 9. Okay. So obviously something's wrong. What am I doing here? It's apply action, right? Check if metagame is over and set appropriate bit 24. So it's my check if the game is over. That's not it's not right. Maybe it's the other way around. Need to do this the other way around, maybe. No, that doesn't change anything. Okay. I need to think about this because this isn't working. This isn't working. All right, what am I trying to do here? I'm basically trying to, let's use an actual example. So this would be our number const bits equals this. All right, here's our bits. Now we want to check. We want to check that all bits are set to 1. So if we do, okay, so C, shouldn't have deleted that. Let's just do bits, 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 bits. Oh, I think I just figured it out. Okay, so I need to do this. Do this and 511, and take that. First 9, like that. Would move, no, let's take the, well, it doesn't really matter really which one we're taking. So we're taking bits and ORing bits shifted to 18. So this is, we're comparing this and that, basically. I'm missing a, right? No, I'm not. What's going on? Oh, that's what's going on. Right. What am I getting if I do this? Interesting. String, maybe. Oh, I've got an error somewhere. No doubt. He's giving me a hard time for this, right? close that. Right. Okay, so but let's be smart about this. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Now let's say we add a 1 here. Doesn't make a difference yet. And we add a 1 here. It'll pick that one up. Cool. So now what I need is to take all of this stuff and do an OR, oops, right here, OR bits. This time we're going to grab these ones. So we're doing that. We're grabbing this entire thing, and we are ending 511. And let's wrap the whole thing. There we go. Isn't that beautiful? So now if I did, if I added a 1 here, let's say, it would pick it up. If I added a 1 here, it picks it up. If I add a 1 here, it picks it up. Perfect. So I can use that. Man, I'm going to be, well, I wasn't going to say good, but I was going to say good, but I'm going to say better at bitwise operators when this is done. Now I just need to change this to state 9. I mean, this is unreadable code. Oh, I'm missing a parentheses. Okay. All right, now let's try this on the real thing. Cool. So we're starting off with this. It should flip this one to 1 for the player. Should flip this one to 1 for 8 here. And it should tell me that the game's over because we're drawn. Now, what if we're not drawn? Damn it! Oh. Why? 1, 2, 3, 4, 5, 6, 7, 8. That's fine. Now the minute I put a 1 in there, yeah. Oh, of course. That is just so... Forgot to check. That is a really dumb mistake on my part. Is equal to 511. Aha. Important. Important. What? Now what? It must be type any bit number or enum type. Oh, now what? Oh. That's because I went and shoved it in the wrong spot. Okay. Okay. Alright, I think we got this. Alright, so. Aha, okay, good. Now let's make all of these. 1, 2, 3, 4, 5, 6, 7. And we're still not showing a game over, but if we add one, boom. Okay. All right, I like this. Or I don't. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it's gonna get rid of this. Now, let's say we were going to do this. All right, we're not game over. But what if I have X win here? Boom, we're game over. Okay, what if this one was not drawn out? Oh, not game over. But what if I have an O win here? Oops, game over. Cool. Okay, now. Okay, so that works. 1, 2, 3, 4, 5, 6, 7, 8, 9. Doom, doom. All right. Now the other thing I need to do is, so this is basically checking for a draw. So check if metagame is a draw. Set appropriate bit. Ooh, what the heck's going on? So let's do that. And then, so if it's a draw, we don't need to check if there's a win. But if there is no draw, we need to check if there's a win. So let's do that here. Check if metagame has been won. Has been won and set appropriate bit. Else if. Now I think I can actually check has won. Use has won. Yeah. Because that's only the X's and O's. So has won. Then I can use state 9. Oh, but it checks it. It checks it for one player. So, well, logically, I only need to check the current player. Yeah, that's right. Has one, state 9, and then how am I calling this? This one has one. New state. New state. New state 9. And players X. And if that's the case, again, we simply set bit number 24. So let's give that a try. Let's say 0's playing. Okay, so 0's playing, and he's already got boards index 0 and 1, and now we're asking him to play in board 2. And let's say in board 2 he actually has already these ones here, so we're asking him to play 2-2, which should give him a win here, and incidentally should give him a win here, which should make him win the entire game. Is that what happened? Yep. We're saying that you need to play the game 2 to board 2. We're saying that next is player X, and we're saying that the game is over. Now, if you didn't have that, what the heck? Wait. we just moved things over. Okay. So that's right. So that works. Let's try it for x. There we go. Next player is 0. Playing board 2. The game has been won. If this was a 0 though, then yeah. Okay. So I think we're in business. I think we're in business for that. We're detecting a win, we're detecting a draw. And I think we're good. Oh, man. So now, where was I? Oh yeah, all of that was to implement the get is terminal, which now is really easy because all we need to do is look at our state. Right, this dot state, I'm looking at index 0, and I just need to check if bit number 24 is checked. How do I do that? I do, and actually I can just return this because no, this won't work, right? Because it's gonna, I gotta switch that to Boolean. All right, so I'll make full-fledged if out of this. If this dot state this would be a cool thing. This would be a cool language feature if you could have a function that's supposed to return a type Boolean, or maybe not a type Boolean, but a new type that would be like Booleanish. Nah, that wouldn't make sense. Whatever. Okay, this dot state 0. What am I doing? I'm checking for bit number 24, so I need to right shift by 24. And once that's done, what do I do with this? I've got this. Now I gotta check if it's flipped. So that would be it would be a and, or it would be a or. No, it would be an and, right? We would want both of these to have their 0-bit on. And if it's the case, we end up with 1. If it's not, we end up with 0. It's cool, so because one's falsy and the other one's truthy. So if it's truthy, then we just return true. Otherwise, return false. There we go. Oh, I wonder if I did it. I'm just trying to think of a way to do it without the if statement. And if I did it that way, let's see. If I'm doing this, now I know this will return either a 0 or a 1. And if I do not strictly equal, but loosely equal, maybe, to true, would that work? What's it saying here? This condition will always return false since the types 1 and true have no overlap. Oh, I guess I'm, maybe I need to wrap this like that. This condition will return false since types number and true have no overlap. Never? Oh. I thought this could have worked. How do you check if something is false or truth? There's got to be a way to do this. I think there is. I mean, like with a language, not with an if statement, but okay, let's see. How to check if something is truthy in JavaScript without an if statement, of course. Is truthy 0, return 0. This won't work if 0 is passed as the value, which is precisely what coercion. Examples of truthy values in JavaScript, which will be coerced to true in Boolean context, and thus execute the if block. Yeah. How can I make this a Boolean context? That's what I'm... Let's see here. Let's think about this. Whatever. I'm not going to waste time on this for now. This should work. Okay. Let's make sure it does. So this will be a new state, right? Which is saying that we have one. No, we haven't. So let's make this. Okay, so node equals new mcts node. We're passing in the state, which has our 24th bit flip, and then we're doing node dot is terminal. It's not a function. I guess it's property, and it's true. But what if it isn't? Then it isn't. But what if it is? Then it is. Okay. Cool. Me likey. So that's that. So we've implemented get. No, wait. What? Where? What? Okay, is terminal. We've got is fully expended already. That's an easy one. We're just checking that the we're not going to need that right now. Right now we need, oh yes, expand. That's what we were doing. Expand. I think we're ready to do this now. except that I'm going off air in about 8 minutes, but that's okay. Let's take a look at what we need to do now and see if we've got all our other functions. So choose an action from the untried actions. So we're cool. So that's what we've got our function here to get all the possible actions. We're going to use that to populate our node. I need to separate this into files soon. Like now. There it is. Yeah, so when we're going to create the node, so we're going to have something in the constructor, I guess, that populates the possible actions left to expand array with the result of our get possible actions function. So then we'll have possible actions left to expand, right? Or untried actions, as they call them here. Maybe I should rename that. Now add a new child. Add a new child. Okay, hold on. Where are we calling expand here? We're calling expand from tree policy. Tree policy, we're calling tree policy from here. V is the state, basically. Okay. So we're calling tree policy with the state. So while the state is non-terminal, no, it's not state actually, it's a node. Alright, so node, yeah. So we're calling tree policy with a node. Is that what we're doing here? So, tree policy with the node. Yeah, cool. Cool. Which would give us a new node. But now inside tree policy, yeah, we got that node. Now we're checking that the node is non-terminal. We're checking that the node is not fully expended. And then we're expending the node. Right. So expand takes the node. It chooses an action from the node. It adds a new child, so a node child, to V. So I need a way to keep track of childs. I need a child array in my node, right? That seems pretty obvious, but let's do that. Private, let's call it children, actually. Note that's going to be more than one. And so it's an array of MCTS nodes. All right. So that's done. Add a new child, V to V, with with state V1. Right. Is equal. So the state of the new node is equal to applying our action here to the state of the node we just passed in. Yeah, of course. So apply node, basically. We've got apply action. So I just run apply action on this node, and then I get a new state, which will be used for the creation of our new node. Oh, and what's that? And a vi equals a. Oh, I guess we would keep track of the action that brought us there somehow. That's not crazy. I'm going to have to think about that. The action that was applied. So each node has a action and state. The action being, yeah, that's not a bad idea. I was just going to deduce the action. And actually that's, yeah, I already had set up something to deduce the action. Where I was going to need that for, I don't know. Am I using that somewhere? Deduce action, right? So, whereas this is just, okay, return A of best child. So yeah, I should just store it. That makes a lot of sense. Less computational. So yeah, let's do that right now. So we're going to call this, let's make this action, yeah, type action, and so when we're creating the node, passing in the state and the action. So actually, I don't need here. I can just shove it right in here. Read only action of type action. Cool. So of course that's gonna okay, which means I can probably call, wait, I can probably call when I create, expand, choose an actions, adds a new child. Yeah, so I can call the new state from within the new node. Does that make sense? With state vi is equal to, no, it doesn't make sense. But whatever. That's trivial to implement, so that's cool. Alright, so we've got our action, we've got this. Now I don't need deduce action. All I'm going to need to do is actually return return find best child return find best child dot action. Yeah, okay, good stuff. Quite happy with this session. I mean, this code is horrible, horrible, because of all the bitwise stuff. And I don't know how I'm gonna make this better, but I'll figure it out. All right, that's it for now. I'll continue tomorrow. See you guys.